Good morning to all. Today we are going to discuss Unit 3 Data Input and Topology. The topic is Coordinate Transformation. So it is an important topic, like we have to change the entirely things, the 3D or whatever we have seen in the world into a map. So coordinate is important in the places. So the coordinate system, the transformation, the outcome of this topic is make use of GIS software for developing raster and vector data model. Like the program outcome is 1, 3, 5, 6, 7, and then 9, whereas the program specific outcome 1. The outcome is make use of GIS software for developing raster and vector data model. So many of new concepts and terms will be found once you introduce to ArcGIS and geographic information system, especially when you are new to this approach. So one of the most important topic that needs to be covered and understood is coordinate system, which is divided into types, which are geographic coordinate system, projector coordinate system. Also, walking through, we will learn more about how system will behave if the projection was not set. So unknown projection and geographic transformation. The key term definition: coordinate system enable geographic data sets to use common locations for integration. So a coordinate system is a reference system used to represent the location of geographic features, imagery, and observations such as global positioning system locations within a common geographic framework. So each coordinate system is defined by the following: so its measurement framework, which is either geographic, in which spherical coordinates are measured from the earth centers, or plane metric, in which the earth coordinates are projected onto a two-dimensional plane surface. Unit of measurement: typical feet or meters for projected coordinate system, or decimal degree for latitude longitude. The definition of the map projection for projected coordinate system: other measurement system properties such as spheroid of reference, a datum, one or more standard parallel, a central meridian, and possible shift in the x and y direction. So several hundred geographic coordinate systems and a few thousand projected coordinate systems are available for use. In addition, you can define a custom coordinate systems. Longitude and latitude. So latitude measure how far north or south of the equator a place is located. The equator is situated at 0 degree, the north pole at 90 degree north or 90 degree, because a positive latitude implies north, and the south pole at 90 degree south. So latitude measurement range from 0 to 90 degree. Longitude measures how far east or west of the prime meridian a place is located. The prime meridian run through Greenwich, England. Longitude measure range from 0 to 180 degrees. So then datum. A datum defines the position of the spheroid relative to the center of the earth. A datum provides a frame of reference for measuring locations on the surface of the earth. It defines the origin and orientation of latitude and longitude lines. Then spheroid. So the Euclidean geometry, a three-dimensional shape obtained by rotating an ellipse about its minor axis, resulting in an oblate spheroid, or about its major axis, resulting in a prolet spheroid. So geodesy, when used to represent the earth, the three-dimensional shape obtained by rotating an ellipse about its minor axis with dimensions that either approximate the earth as a whole, or with a part that approximates the corresponding portion of the geoid. The projection, the method by which the curved surface of the earth is portrayed on a flat surface. This generally requires a systematic mathematical transformation of the earth graticals of lines of longitude and latitude onto a plane. Some projections can be visualized as a transparent globe with a light bulb at its center. But not all projections emanate from the globe center. Casting lines of latitude and longitude onto a sheet of paper. Generally, the paper is either flat and placed tangent to the globe, a planar or azimuthal projection. are formed into a cone or cylindrical and placed over the globe. Cylindrical and conical projections. Every map projection distorts distance, area, shape, direction, or some combination thereof. So to find more projection, visit the map projection site also. So the type of coordinate system, geographic coordinate system. The main aim of coordinate system is to define their location on Earth. The coordinates in GIS datasets can be stored in a geographic projection or local coordinate system. This system uses angles of longitude and latitude to define locations on Earth. On a three-dimensional model of the Earth, the term of geographic coordinate system and datum are often used interchangeably. A datum is only one part of a GCS. Besides geographic coordinate system, the datum and a spheroid, a geographic coordinate system include the unit for longitude and latitude and the prime meridian that has been used for measuring longitudes. So the types of coordinate system, the projector coordinate system. Geographic coordinate systems are good for storing data but not very good for measuring distance. So this is because the angle of longitude and latitude are located exact position on the surface of the earth, but angles does not provide constant distance measurement. Assume that it 30 degrees of latitude and longitude along the equator and 30 degree of longitude close to the north pole represent much different distance. So to measure distance we use projector coordinate system because they define locations on the earth in a flat two-dimensional surface. The coordinates in a projector coordinate system, also known as a Cartesian coordinate system, represent distance from the origin 0, 0 point along two perpendicular axes. A horizontal x-axis representing east, west, and vertical y-axis representing north, south. So the projector coordinate system, in order to apply a projector coordinate system, we need to convert the three-dimensional surface of the GCS into a dimensional one. This mathematical operation is commonly referred to as a map projection. When a data set is projected, the latitude and longitude values are converted into XY values in meter or feet. When datasets covering large geographic areas are projected, four properties of the data are destroyed: shape, area, direction, and distance. When datasets covering small area such as neighborhood or a city are projected, these distortion are often negligible. Projections are categorized according to the spherical properties they preserve. Some projection preserve shape, conformal projection, while other preserve area, equal area projection, distance equivalent projection, or direction true direction, or azimuthal projection. Only one of these spatial properties can be preserved with a given projection. The other ones will be destroyed. Some projections preserve a second spatial property reasonably as well. For example, conformal projections preserve shape, but they also preserve direction fairly well. Equal area projection preserve area but can also preserve distance reasonably well. Alternatively, some projection distort all four of these spatial properties. Projection on the fly. Geographic and projected coordinate system are not only a property of a dataset but also a property of an arc map data frame. There is no default coordinate system for a data frame in arc map. When you open a new map without any layer, the data frame has no coordinate system. To set a coordinate system for the data frame, you can search for the desired coordinate system in the data frame. Properties. Narrow down your search using a spatial filter and selected the appropriate one from the list of geographic and projected coordinate system. Also, you can add a layer with the desired coordinate system as the first layer to the data frame. The first layer that you add to data frame define its coordinate system. Arc map display all layers in a data frame in the coordinate system that has been set for the data frame. This process is called projection on the fly. Projection on the fly. So makes it possible to align data from different coordinate system in the same data frame. When you add a layer to a data frame that has a different coordinate system, then the layer is projected on the fly into the coordinate system of the data frame. The geographic transformation. A geographic transformation defines the mathematical operation for converting the coordinate of a dataset from one geographic coordinate system to another. There may be more than one transformation method available for converting between any two geographic coordinate systems. Each transformation method is designed for a particular area and each has a different accuracy. Example, there are 8 transformation method for converting between the NAD 1983 and WGS 1984 geographic coordinate system. When choosing a transformation method for your data sets, it's important that you are consistent and use the same transformation method every time. Coordinate transformation overview, coordinate system for Earth, ellipsoid and datum. The map projection 3D to 2D, planar coordinate transformation 2D to 2D. The geocoding discrete to continue. The topic for this one, we can ellipsoid and datum, map projection from 3D to 2D. The digital terrain analysis outline, ellipsoid and datum. So a coordinate system for Earth need ellipsoid and then datum. The ellipsoid, a shape used to approximation the shape of the Earth, parameter of a biaxial ellipsoid. The biaxial ellipsoid figure, common ellipsoid, Clark 1866. The World Geodetic System 72 and 84, Harian 1830, Britain GRS 80 US. So the datum, a datum is an actual coordinate system. Creation of a datum, definition of a datum. Steps 1, definition of an ellipsoid AB, attaching the ellipsoid to Earth, initial point and orientation. 5 parameters realization. Then second one is the method, the old approach, definition of an ellipsoid, attaching the ellipsoid to Earth through an initial point with an azimuth to another reference point, survey of monuments. So the drawback, regional and non the common datum. Then the new approaches, definition of an ellipsoid, geocentric, attaching the ellipsoid to Earth, mass center of the Earth. So the three-dimensional, the GPS position of a monument. The advantages is global, geocentric, three-dimensional with Z, the common datum. The coordinate transformation between datum, so Moldex transformation, 7-parameter transformation, surface fitting. Then map projection, the purpose, difficult shape of the earth, distortion, type of projection. So UTM projection, conformal projection, equal area, the state plane coordinate systems. So the assessment part of the session is, what are the types of coordinate system? So list out the types of coordinate system and the list out the types of projection. These are the reference material. Thank you.